At the end of the last video, I asked you to spend some time working through the remainder of example number 2, and hopefully you did that. If you didn't do that, you really do need to go back and work through it again, because it's going to really help frame the conversation that we're going to have now about a new piece of terminology or pieces of terminology. I'm quickly going to go ahead and recap a little bit of what we had near the end of that question. One of the last questions that was on here was that if it was possible, could it have been possible that at the end of the day, we supported the wrong hypothesis? And our answer that we should have come up with there is definitely yes, because we were ultimately just making an educated guess as to which of these two hypotheses we thought was going to be the more reasonable one. And what you should have found in your work is that we seemed to say that it seemed like here H0 was going to be a pretty good fit, where we were going to stick with H0. We were going to put our money on the fact that the cure rate of this disease, or of this new treatment, was 60%. It was just as good as the old one. We didn't have enough reason to believe that the cure rate was over 60%. We didn't have enough reason to say that P was bigger than 0.60. So this is kind of where we landed. But again, we're only making educated guesses. We're making very educated guesses. Like, definitely if someone was going to say, you have to bet $10 right now which one of these things is correct, I'm putting my money on H0 right now every single time. But it doesn't mean I'm always going to win. It just means I might win most of the time. Maybe even a hefty majority of the time. Maybe 999 out of 1,000 times I might win. But there's always a chance we could get it wrong. And this idea of potentially getting a decision wrong is something that we constantly have to deal with in our world. Now, this isn't really a major concept. I mean, you have to deal with this every time that you've ever taken a test, right? Just imagine a multiple choice test. You come across a question, it says, hey, what's the answer, A, B, C, or D? You have to make a choice. And every time in life that you have to make a choice, you might make a good choice, you might make a bad one. And typically the only way you know if you made a good or a bad choice is you kind of have to wait a bit. You have to kind of either, if it's on a test, see the answer key. If it's a decision you make in life, you might have to wait a while to see how everything plays out, right? But usually we don't know at the onset if our decisions are good or bad because we don't have all the information. A very common spot where we have to make decisions in society that's a really great analogy to this process that we're working with here is if you think about a jury. Now, a jury is constantly trying to battle with the ideas of a decision that they are going to make. That is, are they going to claim that someone's not guilty or guilty? And they have to kind of square that with what they actually believe is true in reality. This is what every single juror has to do. They have to look at all the evidence at hand in a trial, and they have to say, okay, I don't actually know what's true, but I'm going to make my decision. I'm going to make my best guess. And what we hope is that our justice system works in a way that most of the time, a hefty majority of the time, that we make the right call. I mean, I guess it's inevitable that we can't always make every call perfectly, but we want to be as close to perfect as we can. That's the ideal. And so you can see kind of here I have a little table set up. Notice that what I'm always going to be squaring is the individual's decision or our decision versus what is actually true. So notice that there are some scenarios where I'm going to be very happy and some scenarios where I'm going to be sad. Let's suppose that as a jury I decide that someone is not guilty, but the reality is that the person is an innocent individual. Well, then we're all smiles, right? I mean, we didn't convict someone that's innocent. That's good. That's justice at its best, right? That's fantastic. But it's also possible that as a jury we could say that a person is not guilty, and in reality they were actually guilty. We just didn't catch them. We didn't think the evidence was overwhelming enough to convict them. And so we don't convict a guilty person. Well, that's not good. We don't want that. But notice that's not the only way we could make a mistake. Depending on if we choose not guilty or guilty as our verdict, we could make a different kind of mistake. So let's go ahead up here and let's suppose that we call this mistake down here kind of like our first type of mistake that we could make, and over here is kind of like a second type. This type of mistake would occur when I say that I believe the person is guilty, but they're actually innocent. That's terrible. That's like sending an innocent person to jail or to prison or something. We don't want to do that. But if I say that someone's guilty and they actually are guilty, then that's great. Well, it's important to note that when we're dealing with hypothesis tests, on every single question, we're really dealing with which hypothesis do you want to go with? And there are two ways that we could make a mistake. If the right answer is unknown, then we have to make a guess. If I make a guess and say that H0 is the right hypothesis, but I'm wrong, I made a mistake. But I could have also said that H1 was the right hypothesis, and that could have been wrong. There are two ways to make a mistake. So we're going to give these types of mistakes names and talk about them. We're going to go ahead and summarize them in the following way. Let's take a look at my revised table down here. It's a bit smaller. Let's suppose that I say H0 is true. That would mean that H0 is the right hypothesis. And remember, this is what's actually happening in reality. H0 could be true or it could not be true. Of course, if we say if H0 is false, that means that H1 is true. And one of these things has to be the case. Now, over here on the side, we have to go ahead and reach our decision. We're either going to choose to reject H0, which means we're going to pick H1 as the best hypothesis, or we're going to not reject H0, which I like to think of as we're going to stick with H0. So we're either going to keep H0 or get rid of it. Now notice again here, if I pick H1, but H0 is true, I make an error. This is really bad. I don't want to make errors, but sometimes it can happen in life. And we'll see here that if we pick H1 and are wrong, we're going to call that the first type of error, type 1. I always remember that because if I pick H1 and I'm wrong, I made a type 1 error. However, if I decided to stick with H0 and I was wrong, I make a type 2 error. In any other arrangement, everything was great. I stuck with H0 and H0 was true. That's good. I picked H1 and H1 was true. That's good. I like those scenarios. Well, what we want to go ahead and understand is that there is probably going to be some percentage of the time that we're just by accident going to make one of these errors. And these percentage chances of the time are what we're going to go ahead and define with these Greek letters. So let's take a look at the boxes up here. Type 1 error occurs when we reject H0, that is, we pick H1 when H0 is true. We pick H1 and we're wrong. It's the equivalent of convicting someone who's innocent. And the chances that that's actually going to happen, we're going to denote with this Greek letter right here, which is actually called alpha. Looks like a little fish, okay, kind of like an A, but it's Greek letter alpha. Now a type 2 error is when we stick with H0 when H0 is false. It's like setting a guilty person free. It's not good. Errors are always bad things. They're just different bad things. But we're going to represent the likelihood that that happens with a Greek letter that's called beta. Okay. Now, there's obviously no reason in life that you would really want to make an error, right? You don't want to make incorrect decisions. But, again, what we're going to see is that that's partially unavoidable. Imagine that I was someone on a jury who was really, really, really terrified of doing something like up here, like convicting an innocent person. Like, can you imagine how guilty you would feel if you found out, like, years later that you were on a jury and you accidentally sent someone to prison maybe for like 20 years, but they were innocent? That's got to be unthinkable. Like, I can't wrap my head around what that would feel like. I'd feel so horrible, right? But if I was really nervous about doing that as a juror, I might be really cautious about throwing out the verdict of guilty because I don't want to convict someone that's guilty. But notice that the moment that I start decreasing the number of times that I say guilty, that's going to increase the number of times that I vote not guilty. So as I decrease the chances of making this mistake, I'm going to be increasing the chance that I make this mistake, right? If I start voting not guilty all the time, I might accidentally not convict someone who should have been convicted. That's also bad. But notice that if all of a sudden I get panicky as a juror and I go, oh my gosh, I've been not convicting guilty people. I've been sending these guilty people back out to the streets or something. I might all of a sudden say, I want to decrease this, and I'm going to start to say that, I want to vote not guilty, like never. Like I want to make sure that I convict these people that are guilty. So I start, throwing out guilty votes way more often. Well, the moment I start trying to decrease making this type of mistake, I'm going to increase making another type of mistake. This is terrible. I mean, errors in life are unavoidable. They're going to happen. And as I see here, I can say that minimizing type 1 error results in increasing type 2. Minimizing type 2 results in increasing type 1. I can't get away from error. I can only think about maybe which errors I more prefer. If I had to make a mistake, and this is not an easy call to make, would you rather convict an innocent person or set a guilty person free? There's not a right or wrong answer there. This is like something outside of mathematics. This is like a moral question, right? Like we're asking things that are not mathematical here. But the mathematical side says, don't pretend you can avoid it. You can't. You just have to kind of say, well, what would you rather do? Would you rather convict an innocent man or not convict a guilty man? There's no way to make that call. But if you're on the jury, you have to think about that. Well, let's take a look here quickly at example 3 to see how we can deal with these different types of errors. And we'll relate specifically back to the idea that we had back in example number 2, where we had this medicine and we had two hypotheses that were kind of squaring off against each other. We had hypothesis 0, the cure rate is 60%, and hypothesis 1, the cure rate is over 60%. Now, at the end of the day, we know that we picked H0 as the hypothesis that we were going to go with. This, again, in blue, was our decision. Well, let's see if our decision pans out in example number 3. Let's suppose that the true cure rate of the medicine was 62%. Then did we make the right decision? Because we said the cure rate was 60%. Well, then definitely here we would say, no, we made an error. And specifically, we should be able to narrow down what kind of type of error we made. So again, let's see. We stuck with H0 and were wrong. If you stick with H0, but you end up wrong, that's a type 2 error. Okay, let's see. What if, though, it was the case that we found out that only 60% of people would end up being cured by the drug? Did we make a mistake then, or was our guess really good? Well, in this case, we definitely can see that we made the correct decision. All right, let me write it like this. The correct decision was made. Right? So I can see here that I can interpret my decision once I actually know the answer. There's no way to know ahead of time what error you made or if you even made an error until you actually get the final answer. That is, until statistics is kind of over. Statistics, remember, is about making educated guesses. So statistics is living in a world where we never know the final answer. Right? I may never know the actual cure rate of the disease, but I want to take an educated guess, and I want to be aware of what type of mistake I might be making. Now, the last thing that I'll mention here is that this value of alpha, which represents the probability of making a type 1 mistake, is also going to go by another name. We're often going to refer to it as a level of significance, and it's going to be standing for the maximum allowed probability of making a type 1 error, the chances of making a type 1 error. And it's common practice to assume that this value of alpha is at 5% unless otherwise specified on a problem. And we'll see more about what that looks like a bit later.